Hello everyone. Welcome to EquaticMath. This is Pranjal. Today we are going to discuss Chapter 1 of Class 9th Number System Part 3. Now today our topic is irrational numbers. What are irrational numbers? All real numbers that are not rational, that is, which cannot be written in the form p by q, where p and q are integers and q is not equal to 0. Those real numbers are irrational numbers. As we know that those numbers which are of the form p by q, where p and q are integers and q is not equal to 0, they are rational numbers. So those numbers which are not rational are known as irrational numbers. Those real numbers which are not rational are irrational numbers. Now, non-terminating, non-recurring numbers. We learned about the decimal expansions of rational numbers. Now in the similar manner, there are some more decimal expansions, and that decimal expansion which is non-terminating, non-recurring. Non-terminating means which never stops, and non-recurring means non-repeating, that is which does not follow any pattern. Those types of decimal numbers are irrational numbers. For example, root 2. We know the value of square root 2. It is 1.4142 up to so on. It continues up to so on. So it is non-terminating, and there is no pattern followed by any number. So it is irrational number. Similarly, root 3 is 1.732 up to so on. It is also non-terminating and also is not following any pattern. So it is also non-terminating, non-repeating number, or we can say non-terminating, non-recurring number. There is one more example of non-terminating, non-recurring number, means irrational number, that is pi. We all know about pi. Its value is 3.1415 up to so on. It is also non-terminating, non-recurring, that is non-terminating, non-repeating, and hence we can say that every non-terminating, non-recurring number is irrational number. As root 2 is also an irrational number, root 3 is also an irrational number, pi is also an irrational number, and hence we can get many more examples of irrational numbers. Now, next is a question. Classify the numbers as rational or irrational numbers. Okay, see the first one, A part. It is 0.3796. It stops after 4 decimal points. So it is a terminating number, and we know that terminating numbers are rational numbers. So 0.3796 is a rational number, right? Now see the B part. It is 1.010010001 up to so on. It continues, right? It is continuing, means it is non-terminating, but it is not following any pattern. We can clearly see this. Non-terminating and not following any pattern means non-terminating, non-repeating, and non-terminating, non-repeating are irrational numbers. So B part is irrational number. Okay. Now C part, root 23. Now root 23 is not 23 is not a perfect square. So square root of 23 is an irrational number. Okay. Now next one is root 225. We know that 225 is equals to 15 square. So we can say that square root of 225 is equals to 15. And 15 is a rational number. It means root 225 is a rational number. Okay. Now let's move to the E part. E part is 150, 1500, 1500015 up to so on. It is non-terminating as it is continuing, and non-repeating is not following any pattern, so it is non-terminating, non-repeating, so it is an irrational number. Okay, now last part, F part is 0.8 bar. See, 0.8 bar means 0.888 up to so on. It is non-terminating, right? But it is following a pattern. 8 is repeating. It means it is non-terminating repeating number. And we know that non-terminating repeating numbers are rational numbers. So 0.8 bar is also a rational number. Clear? Now see the next part. Now we will discuss how to plot the irrational numbers on number line. Okay? Let us take an example. We are plotting square root of 3.5 on number line. 3.5 is not a rational number, so it is an irrational number. Now we will discuss how can we plot root 3.5 on number line. See, I have written the steps for you. We will just follow the steps. You have to learn the steps, and hence you can plot the irrational number 3.5, root 3.5 on number line. See, for this, first step is take AB equals to 3.5 units. We have to first take a line which is of 3.5 centimeter. See, we are taking this like from here I am starting, and I am taking this as A and this is B point, and it is of 3.5 units. Okay. Now the second step is you have to mark 1 unit from point B up to point C. From B, mark distance of 1 unit up to point C. Means this is point B, and you have to mark 1 unit from point B up to point C. Suppose this is point C and it is 1 unit. Okay. Now from here we get 3 points A, B and C, where AB is 3.5 units and BC is 1 unit. Now in the next step we have to find out the midpoint of AC. Just take the scale and plot the midpoint of AC. Okay, let us take this point. This is the midpoint of AC and we will mark it as O point. Okay, third step was you have to find the midpoint of AC and we have to mark it as point O. Now with center O, we have to take O as the center and OA as the radius. We have to put the compass point on O and open the compass and point the pencil on A. You have to take O as the center and OA as the radius, and you have to draw the semicircle. Okay, now the next step is, after drawing the semicircle, see the fifth step, you have to draw a line perpendicular to AC, passing through B and intersecting semicircle at D. Okay, this is the perpendicular line. Now the next step is, then BD is equals to root 3.5, means we have to just point out this point as D, which is on the semicircle, which is intersecting with the semicircle. Now this BD is square root 3.5 units. This BD we got is 3.5 square root. Okay, now we have to draw an arc with center B and radius BD, which intersects the number line in E. Now we have to draw an arc taking B as the center and BD as the radius, and we have to draw an arc on the number line. When we draw the arc on the number line, the point at which this arc intersects with the number line, mark it as point E, and this point on the number line is square root 3.5. Okay, and hence we got the irrational number root 3.5 on number line. See, let me explain it again. In first step, we have to take AB as 3.5 units, this A point and this B point as 3.5 units. Now after that we have to mark distance of 1 unit from B point up to point C. Now after that we have to take the midpoint of AC, and from that midpoint, using that midpoint O, we have to take that midpoint O as a center and OA as the radius, and we have to draw a semicircle. When we drew the semicircle, from point B, we have to draw a line that is perpendicular at point B, and it is intersecting the semicircle at point D. Now in the next step, we have to take the compass and taking the B as the center now and BD as the radius, we have to draw an arc, and this arc intersects the number line at point E, and that point E is root 3.5 on the number line, and hence we got the root 3.5, which is an irrational number on the number line. Clear? Now next is operations on irrational numbers. Now first is, we can when we apply the operations on irrational numbers, like irrational number plus, minus, multiply or divide with the irrational number, it can be rational or it can be irrational number. Like sum of two irrational numbers need not be an irrational number. Like we have two irrational numbers, root 2 and root 3. Both are irrational, and hence their sum is also irrational. Next is 4 root 2 plus 6 root 2. It is 10 root 2. It is also an irrational number. Next, 2 root 2 plus 3 root 3 plus root 2 minus 3 root 3. When we open it, this and this got cancelled out, and it is equals to 3 root 2. It is also an irrational number. Let us take one more example. If we take 3 root 2 plus 4 plus 3 minus 3 root 2. If we see, we can cancel them out, and 4 plus 3 is 7, and 7 is a rational number, right? So we can say that sum of two irrational numbers may be rational or an irrational number. Sum of two irrational numbers need not be an irrational number. Similarly, if we talk about the difference of two irrational numbers, it can also be a rational or an irrational number, means it needs not be an irrational. Let us take the examples. 3 root 2 minus 2 root 2 is root 2, which is irrational, right? Next, 2 root 2 plus 5 root 3 minus root 2 minus 3 root 3. When we solve it, we will get 2 root 2 plus 5 root 3 minus root 2 plus 3 root 3. When we solve it, 2 root 2 minus root 2 is root 2, and 5 plus 3 root 3 is 8 root 3. It is also an irrational number, right? Now let's see the next example. 7 plus root 5 is an irrational number, minus root 5, it is also an irrational number. When we take the difference of these irrational numbers, here root 5 and root 5 will get cancelled out, and it is equals to 7, and we know that 7 is a rational number. So we can say that difference of two irrational numbers need not be an irrational number. Clear? Next is, we have some formulas here. These formulas says root AB is equals to root A and root B. Means if I take an example, root 2 multiply 3, means if we take root 6, right, we can write root 6 as root 2 multiply 3. It is also equals to root 2 multiply root 3. Okay. Next is similar way, root A by B, it is equals to root A by root B. Clear? We can separate them out. Next is root A plus root B into root A minus root B. See, here it is written that A minus B. We know now there is a formula A plus B into A minus B. It is equals to A square minus B square. In the similar manner, here we are taking root A plus root B and root A minus root B. So it will become root A square minus root B square. So root A square is A and root B square is B. So the answer is A minus B. Clear? Now see the next one. Next is A plus root B minus into A minus root B. Now the next one is A plus root B into A minus root B. It is also the same type, A plus B into A minus B. Here we have to take the square of A, it is A square, and minus root B square. A square can be written as A square only and minus root B square can be written as B only. So the answer is A square minus B. Clear? Now the next is root A plus root B into root C plus root D. See, in this we have to multiply this one by this one first. Root A into root C is root AC. Next, root A into root D is root AD. Next, we have to multiply this root B by the second bracket. Root B into root C is root BC. And root B into root D is root BD. Clear? Now the next one, root A plus root B square. It is root A square plus 2 root A into root B plus root B square. See, root A square is A plus, we know that we can write root AB as root A into root B as root AB only. So it is 2 root AB and root B square is B only. See, this and this are the same, hence we get the formula. Similar manner, see the next one, root A minus root B square. We know that A minus B square is A square minus 2AB plus B square. So here we have to write root A square minus 2 root A root B plus root B square. Now root A square is A minus 2 as it is, root A into root B is, see the first one, it is root AB, so we have to write it as root AB plus root B square is B. So we can write it as A minus 2 root AB plus B. Clear? Now see the next one. We were doing the operations on irrational numbers. Now the third is product of two irrational numbers need not be an irrational number. Like if we are taking the example root 3 into 7 root 3. See, 7 we can write it as it is, and we have root 3 and root 3 two times, so it will become root 3 square. So it is equal to 7 multiplied by 3, it is 21 and it is a rational number, right? Now if we take the second example, root 5 into root 7. It is the formula root AB equal root A into root B. Similarly, we can converse it also. Root A into root B is equal to root AB. So root 5 into root 7 is equals to root 5 into 7 and it is equals to square root 35. And it is not a 35 is not a perfect square. It means square root of 35 is an irrational number. Clear? Similarly, we can check them out. Okay. Now the next is quotient of two irrationals need not be an irrational number. Means it can be rational or it can be an irrational number. Now let's see, we are taking an example 8 root 15 by 2 root 3. It is a rational number or an irrational number. Let's check. Now 8 root 15, we can write 8 as it is, and root 15. Root 15 is a multiple of 3 and 5. 15 has two factors, 3 and 5. So we can write root 15 as root 3 multiply root 5. And in the denominator we have 2 and root 3. Now if we see 8 and 2, we can cancel them out at the table of 2. So we will get 4 and 1. And we can also cancel the root 3 by root 3. Hence we got the answer 4 root 5. As root 5 is an irrational number, so 4 root 5 is also an irrational number. But if we take an example like 3 root 5 by 4 root 5, then in this example we can cancel root 5 by root 5, and hence we will get the answer as 3 by 4. And 3 by 4 is p by q form, where p and q are integers and q is not equal to 0. So it is a rational number. So hence we can say that quotient of two irrationals need not be an irrational. Clear? Now see the next thing. We have got the conclusion about real numbers. See, the first point is a number whose square is non-negative is called a real number. Means if we are taking the square root and we have suppose 23 and I am taking the square of that number, it is equals to 23. It is a positive number, so it is a real number also. Okay. Now if I take square root of minus 23, then the square is minus 23. It is not positive, means it is negative, so it is not a real number. It is not a real number. Clear? Now the second is collection of all rational numbers and all irrational numbers are real numbers. We had already learned now that what are irrational numbers? Those real numbers which are not rational are irrational numbers. So from there we can say that all rational numbers and all irrational numbers collectively are known as real numbers, right? And next is between any two real numbers there exist infinitely many real numbers. Means if we have two real numbers and we have to find the any other real number between those given two real numbers, then we can find infinitely many real numbers. Clear? So it was all for today. I hope you liked the session. If you like, then please hit like and subscribe. Press the bell icon, do comments, do likes as much as you can. Thank you very much. Bye bye. Let's meet in the next session.